So today we're going to take a look at how to use or how to put complex numbers into polar form and how that can be useful when calculating the different operations with the complex numbers. First thing, in terms of plotting, a complex number is going to be similar to a coordinate. So when we're converting back and forth, it'll be similar to converting from rectangular to polar. For example, this point here would be 3 plus I. So similar to 3 comma 1. Do a different color for the next one. Another point could be -2 minus 3I. So the real axis is like our x-axis, and the imaginary axis is the y-axis. Again, the point that's in red could be similar to the point -2, -3 when we're working on converting. Because we're going to be working with the polar coordinates, something that you're going to want to do is find what's called the magnitude, similar to your idea of vectors. So I'm going to plot the point -2 plus 5I. The distance from the origin out is going to be our R value later on. When we're talking about vectors, and also the complex numbers, finding that distance is represented by the absolute value symbols. You're finding the absolute value of the complex number. So all we're doing is essentially doing distance formula. -2 squared plus 5 squared, we get square root 29. And that's that distance out from the origin. So next, when we represent this in terms of polar coordinates, it's going to be a similar idea. We're going to get an R value and a theta. The only thing you have to draw in here is the theta. That is our angle measurement there. Recall, to go from rectangular to polar, we need the following formulas. A equals R cosine theta, and B would be R sine theta. We also know that R squared is equal to A squared plus B squared. I'm actually going to take the square root of that. So that's something we will use later. So if we're using A plus BI, we're trying to convert that over, we're going to substitute in R cosine theta for A and R sine theta for B. Something that you'll notice when we go to do calculations later on is that we'll factor out the R because we can work with those two pieces kind of separately. So I'm just going to show that here. Now this will help us with converting back and forth, which is what we're going to do to wrap up this video before we do another video that talks about the operations we can do by putting these complex numbers in polar form. So first thing we're going to do is take the rectangular complex number and change it over into polar form. It's like converting rectangular to polar points. So when we're doing this, we're going to want to determine the quadrant, and when you're thinking about the quadrant, think about how you would plot this or write this as a point. So really what you're thinking about is -2, -2 root 3, which is in quadrant 3. That's going to be important when we come up with the radian or degree measure. We're going to do radians for these, although we could do degrees. We're then going to find our R value, and then theta. And you can do these in either order. So we'll do r is equal to square root of negative 2 squared plus negative 2 root 3 squared. That's going to equal 4. And I'm going to go quickly through the calculations for that stuff. You can always go back and check that with your calculator. And then we'll do tangent theta equals y over x, just like we did before. So this kind of comes full circle and brings us back to what we did at the beginning of the unit. Now here's where you have to be careful. Our reference angle for this is going to be pi over 3. But we're looking to get the value in quadrant 3. So in quadrant 3, theta is going to be 4 pi over 3. Therefore, instead of just writing 4 comma 4 pi over 3, we're going to write 4 times cosine 4 pi over 3 plus I sine 4 pi over 3. And that's going to be how we would represent it in polar form. There's going to be a lot of good operations we can do with this and things that would actually be a little tougher to do in the rectangular format. Okay, so this next one we're going to do the same exact thing. We're going to take the point 6, negative 6, decide the quadrant. So this is going to be in quadrant 4. That's going to be important for our angle. Our r is going to be square root of 6 squared plus 6 squared, which is square root of 72. You're going to want to make sure to simplify any radicals that you get here. And your tangent is going to equal negative 1 over 1. Since we're in quadrant 4, you could put a negative angle. We're going to go with the 7 pi over 4. If you are coming up with these yourself, keep your answers between 0 to 2 pi. So our final value for z in the polar format is 6 root 2 cosine 7 pi over 4 plus I sine 7 pi over 4. I'm going to do one more thing in this video. If you need to pause for a minute, just kind of get everything written down and then restart, you can. It's kind of getting a little long. The other direction is going to be actually a lot easier, just like it was in the polar format, because all we have to do is calculate to go from polar to rectangular. So we are going to just evaluate cosine of negative pi over 3. So it'll be square root 8. Cosine of negative pi over 3 will be 1/2. You have to worry about the quadrants here, but you can also kind of check this out with your calculator. Plus I times the sine of negative pi over 3, which is negative root 3 over 2. Now, I didn't do this right away, but you could simplify the square root of 8 to 2 root 2. And what this will help with is when you go to distribute, it'll be a little easier to simplify. So this will come out to root 2 minus root 6 I. And then the last one, cosine of 2 pi over 3 is going to be negative 1/2. I sine of 2 pi over 3 will be root 3 over 2. And you can distribute. So this again will involve needing to know those exact values like at the beginning. But going that direction is going to be a little easier because the quadrant stuff will already kind of be given to you.